Hello, my name is Lauren Ellis and I have created this video for Lab 9 for Physics Course 102. During this video, we will talk about the physics of a toaster.
When you get up in the morning, you may make yourself a piece of toast, or even toast a bagel. But have you ever really wondered how the toaster works? In this video, we are going to dive deep into the physics of a toaster and how a toaster works. There's a lot more to learn about than you may think. There are many different parts of the toaster, and the first one we will be focusing on is the plug.
Three main wires. There is the neutral wire, the earth wire, and the live wire. These three wires help to connect the circuit and help give power to the toaster.
The live and the neutral wire work together to complete the electrical circuit of the appliance and run energy in and out of the toaster. The energy these two wires work with is called an alternating current, also known as AC. It runs through most houses and thus through the wires in the toaster. AC is an electric current that reverses its direction backward and forward very quickly. It is used because it is more efficient and can travel for longer. That's why it's typically found in households. This is in comparison to DC power, otherwise known as a direct current, which is often used to power lower power needing items like computers and other devices. It is a basic building block of integrated circuits. Another part of the plug is the fuse. The fuse is an important part of the toaster, but it can also be found in houses. A fuse can be defined as a safety device that protects electrical circuits from the effects of excessive currents. Fuses help to control the amount of current, so if the current becomes too high, the fuse breaks and then the appliance stops working.
May cause problems in this aspect because they need more current to be powered compared to something like a light bulb. Especially when other appliances are also plugged in, there is always a possibility that there may be excess current that needs to be controlled via the use of a fuse. Another thing that was added to the toaster to help protect users is the addition of insulators, especially around the plug. While there are conductors in the toaster, such as nichrome, which is an alloy of nickel and chromium that help to transfer heat onto the toast, the insulators can be found around the plug and around parts of the toaster. An insulator is something that electricity struggles or cannot pass through. These insulators cover the wires and the parts of the plug so that the electricity cannot pass through them while going to the toaster. One of the most well-known qualities of the toaster is the so-called lever. This is controlled by an electromagnet. An electromagnet is defined as a current-carrying coil of wire with an iron core whose magnetic field is produced by electric current. The electromagnet is connected to a transistor, which is connected to the main IC. In this case, IC stands for integrated circuit.
Because of this connection to the IC, when the toast is done, the main IC kills power to the transistor, which then kills power to the electromagnet and disengages it. One of the things that is interesting is that when the toaster is not plugged in, the lever will not stay down. The reason why this happens is because the lever is controlled by the electromagnet, it needs to have electricity running through the toaster in order for the lever to stay down and thus the electromagnet to be engaged.
Like I said before, conductors are a very important piece of the toaster. If you look in the drawing, you'll see these red beams, and these are meant to represent the heat. Near those, there are wires. These wires are conductors. The conductors allow for the heat to be spread evenly throughout, and they also allow the energy to be turned into heat as it travels through the wire. Conductors allow for an even toast and help to add more surface area that is being toasted to the toaster. Since we have gone over so much in this video, I thought it would be good to end with a conclusion about what we have learned. We learned about how insulators and conductors work and how they impact the toaster, and how conductors help spread the heat evenly while insulators help protect users from high levels of electricity. We also learned about fuses and how the fuses can prevent users' danger if there's too much current. We also learned how this can be applied in household situations. We learned about electromagnets and how they're used to control the lever when it goes up and when it goes down. Along with all that, we learned about alternating current, which is an electric current that reverses its direction quickly. We learned how it is used in toasters and electricity, and typically households, due to the fact that it's efficient and can travel for longer than direct current. In relation to all this, we learned about electrical plugs. We learned that electrical plugs have 3 different types of wires and also contain these fuses previously mentioned. And these electrical plugs help convert and change the energy so that it can be used in appliances. Had a nice time and enjoyed the video while learning a lot. Next time you make your breakfast or use a toaster, think about all the physics that's involved.